Security needs to be thought about at all phases of the information lifecycle. We don't want to add band-aid solutions at the end because that's usually more costly, takes more time, and doesn't solve the problem as if you had done it before during the information lifecycle. One important part of the information lifecycle is the consent to be allowed to gather data in the first place. So this means that we have to think about getting consent to get the data, but also having consent to use the data in a variety of ways through the life cycle. And the implementation on how we do that will vary. It really is factored by thinking about regulations and laws that apply that we must adhere to. An example of which is the GDPR in the European Union. Let's take a look at the information lifecycle phases, starting with collection. Now, in the GDPR, to be specific, European Union citizens have to be made clearly aware that their data is being collected and that they consent to it. Then there's the storage of that data, the processing, the sharing, and the eventual archival and deletion of the data. Many regulations apply to some or all of these phases. For example, GDPR again would apply to deletion. European Union citizens have the right to have access to their data to make it correct if there are errors, or to remove it when they no longer want it out there. And this is applied regardless of where organizations are and where that data is. It doesn't have to be physically stored within the EU. Yet in other cases, that will matter. The physical location will have an impact on which laws and regulations apply. So it does vary. Now, when we talk about protecting sensitive data, we're talking about things like personally identifiable information, or PII, PII, that we've already mentioned. So really, this is one or more pieces of information that can be uniquely tracked back to an individual user. So what kind of things constitute PII? Well, we've got social insurance numbers in Canada or social security numbers in the United States, email addresses, credit card numbers, your home address, your mother's maiden name, web browser cookies that might contain unique session information. All of that can be uniquely traced, potentially, back to an individual. And so many data privacy laws and regulations that are designed to protect that type of data. On the health side, we have protected health information, or PHI. This is similar to PII, but it's got a medical twist to it. So one or more pieces of sensitive medical information that could be tracked back to a person. So that would include things like a health insurance plan number, blood type, patient medical ailments. Now, you might say that blood type might not trace back to an individual because a lot of people have the same blood type, and that would be correct. But if you start combining that with other information, it could be traced back to an individual. And so there are laws and regulations in place in different parts of the world to protect PHI. There are a number of different technologies that are used to ensure this data privacy, one of which is anonymization. The idea with anonymization is we want to take data sets that have sensitive information, but we want to swap out or remove sensitive information that could tie it back to an individual, yet keep the remainder of the information maybe for statistical number crunching purposes. So the GDPR, the General Data Protection Regulation for the European Union, allows anonymized data collection and use without user consent. That's interesting, because when we talked about the information lifecycle and the GDPR, we talked about that European Union citizens must be clearly made aware that their data is going to be gathered and they must consent. But that's if it's not anonymized. So the rules change a little bit when we anonymize. So anonymized data then might have marketing values that are lesser than if it was individualized data that could be tied back to users. It really depends on the type of data and how it needs to be used. However, there are a couple of anonymization techniques that can be put in place, one of which is pseudo-anonymization. This means that we're replacing any unique identifiers, any personally identifiable information, with some other identifier or outright removing it, while leaving other information that is not personally identifiable information. Think about our blood type example. If we've got a lot of data sets related to medical blood types with patient information, by removing or replacing unique patient information with something else, we are anonymizing the data while retaining blood types. And maybe we're interested in how many people have a certain type of blood type. Data minimization. This means that we limit how much data that we are storing or retaining. An example of this, if you think back, is PCI DSS for merchants that deal with credit card and debit card sensitive information. Do they need to retain it? Often, the answer is no. They need credit card and debit card information to process a payment through a transaction, but after that, usually it doesn't need to be retained. That's where data minimization kicks in. You only retain what you absolutely must and what you're legally allowed to. Anonymization techniques also include tokenization. Perhaps at some point you've used your smartphone to make some kind of a payment using an app, and maybe that app is tied to your credit card. So instead of actually using your real credit card to make payments and passing that information over the internet, so credit card number, credit card holder name, and so on, instead, we can use a service or an app that will create a unique token based on that source information, based on our credit card number, based on the expiry date, and so on. And so what we can then pass off to merchants that require payment is a token, which means that there has to be trust established between the services that generate these anonymization tokens and the apps that consume them. But what we don't want to do is actually send out our credit card information. Instead, we want to send some unique representation of it that is trusted and can be used in this case for payments. Data masking is another anonymization technique. You've probably seen this before when you've gone to a retail outlet and paid for something with your credit card and you've received an old school paper receipt where your credit card number is not displayed. Maybe the last four numbers are or something like that, but the rest of it is masked out. Another example of data masking is when you sign into a website with a password, the password is usually masked. Some options might allow you to view the actual text, but usually it's masked out. So those are examples of anonymization techniques. Now that starts to move into the territory of data where we think about sovereignty. Data sovereignty really deals with where the data is physically. Where is it located? Now we know even in the cloud that data is stored on some kind of storage array somewhere in somebody's data center. But we need to know where because there might be different laws or regulations that might apply depending on where the data physically resides. So where did the data originate? That can be important. Where is it now? And which laws and regulations apply? So let's take a look at where we might have some level of control over where data is in the Microsoft Azure cloud. Okay, so here in the Azure cloud, I'm in the Azure portal. I'm going to open up my left-hand navigator where I want to go down to my storage accounts. This is where we can store enterprise data in the Microsoft Azure cloud environment. When we look at the properties of an Azure storage account, I'm just going to open an existing storage account where I've got some data stored. We have the option of seeing where the data is currently stored and whether or not it's been replicated to another location. And it's the replication that we really need to be aware of, because if you're replicating data outside of current national boundaries to an alternate country, well, different rules might apply to that sensitive data if you've got sensitive data stored there. So here in the properties of my Azure storage account, over on the left, I have the geo-replication option. In this case, it's already been enabled to save us some time, but if you take a look over here on the right, I've got it stored in Canada East and Canada Central. So they're both in the same country in this particular case, as evidenced by looking at the map, depending on how good your geography is. But in some cases, you will have the option of replicating data to alternate countries, which means, as we said, different rules might apply. So it's important to know that. So when it comes to the information lifecycle and data privacy, we have to think about applying data privacy rules as applicable for all phases, from the collection of the data all the way through to its eventual archiving and or deletion.